So let's get started. Hello everyone, my name is Mihai Balach and I'm your host for this meetup. So due to these difficult times, we decided to move this meetup online, and in order to keep the cadence, we also decided to skip the beers. I know that hurts. However, we will make it up to you next time, I promise. So before we start, let me thank our guest presenters first and remind you to use the chatbot for questions. Also, please keep the microphone muted during the sessions. And if that was said, let's get into secrets with our first presentation today. Guys, you can take over and share your screen.
All right. Hi, everyone.
Hi.
Hello.
Can you see my screen?
Yeah.
Yes.
Okay. My name is Alexander. Me and Alex, we are systems engineers at IPAM Netherlands. And today we're going to talk about our journey of management secrets. Before we get started, we'd like to describe a little bit about our environment, about our automation toolset that we use every day. After that, we'll cover secret management issues, requirements, and possible solutions. Moving on, we'll briefly describe how HashiCorp Vault, how it works, and we'll shed light on use cases and how we implemented it with Jenkins, with Terraform, and Ansible. And finally, we're going to show you our demonstration. If you have any questions, we're ready to answer it at the end of session. All right. So our current project is all about disaster recovery, and that solution is based on Amazon Web Services Cloud. We tend to use infrastructure as code. We run Terraform to spin up infrastructure part. We deploy our applications with Ansible, and we manage it using Jenkins job and Jenkins pipelines. Okay, but how about secrets? Alex?
Okay, thank you. So let me share my screen. Yeah, I believe you can see it now. So, okay, guys. So when we are talking about our secrets, and more specifically, when we are talking about our passwords, we usually end up with the list of the issues you can see on your screens right now, right? So for us, for engineers, I believe it might be obvious that we shouldn't actually use the same passwords for everything, or we shouldn't share our passwords with other people, and basically we should rotate them frequently in order to avoid any kind of security issues. But you know, we are all human beings and we all make mistakes, right? So our goal was to avoid those mistakes and protect our secrets with the solution we are looking for. So in order to do so, we made the following list of the requirements for a secret management. So the solution must be centralized with the policy-based access to our sensitive data, and we also expect from it to be integrated with our tools like Ansible, Jenkins, and Terraform without any issues. The solution also should have GUI and CLI/programmatic access. So we also would like to move with a cloud agnostic solution and have it reliable and scalable. So I do understand that it might sound like we want something impossible, but let's see. Let's see what do we have at the moment to address those issues and fit our requirements. So we ended up with the following solutions. So we can use yellow sticky password.txt file on our desktops, or even personal password manager like NordPass or 1Password, for example. So the yellow sticky will not work because, you know, we would like to save our trees for kids, and the rest, they just don't meet our requirements, the one you saw on the previous slide. So we also actually may hard code our secrets into source code and rely on policies assigned to our repos. But sooner or later, one of the engineers will push production code to his personal GitHub account, and it just doesn't work for us. That's because of this. Well, solutions from cloud providers might work, but we really would like to avoid a headache with a cross-cloud integration in the future when we extend our solution to GCP or Azure, for example. So, and surprise, we ended up with a solution from HashiCorp, Vault. So let's look at it. Just a few words about HashiCorp. I believe that you guys all know this company, and it's a very famous company in the DevOps world. Most probably you know their products like Terraform, Vargant, Consul, and Vault. So today we'll just cover Vault. And so they have, of course, they have a website for this. It's vaultproject.io. The good thing about Vault is that it's an open source product. So basically, you can easily check their codes. You can make sure that they're not going to steal your data. They're not going to upload them anywhere. And since it's a source code written in Golang, you basically can build your own version of their products, or you some kind of may update it, etc. So it's an open source. Another good thing is that they deliver it as a single binary file. So basically you have, in order to run a server and a client, so you will use exactly the same binary file. I think it's really great because you don't have to think about all of those dependencies like, okay, I have server with version 1.40. Should I use a client 1.40, or I can use client, for instance, 1.32, something like this. So actually you can just publish a single file and it's going to be used for everything. Another good thing about HashiCorp, and especially Vault, is that they have a really good documentation. So there you can find almost everything related to their products. Another good thing about their documentation is just it's an open source as well. So basically, if you found any issues or if you would like to add something, feel free to do this. As soon as HashiCorp approve your pull request, everybody's going to see it. And I also would like to mention that they have really great Learn portal, learn.hashicorp.com. And there you may find a lot of useful video lessons, quick starts, and some of use cases. I personally believe that they covered almost everything there, but if something is not covered, so feel free to raise an issue on their issue tracker. And I believe that HashiCorp will reply on your request anyway. Okay, so if you look at the Vault, you may notice that it looks like a classic tier 3 architecture. So we literally have backend, frontend, and the business logic part. So let's look at them closely. So the front-end part consists of HTTP/HTTPS API server, and all interactions with the Vault will go through it. So basically, as a response, you will get a JSON document. So as you may notice, you can use this in your Python scripts or even write your own GUI for your users. So if you don't like, for instance, the default web UI from the HashiCorp Vault, because I believe it's super easy to work with the JSON outputs. The barrier is kind of a business logic part, and it's the place where the magic happens actually. The barrier takes care of encrypting, access to your data, audit, and logging, as well as all other things, which actually makes Vault so cool for secret management. So it's the heart of the Vault, I would say. A storage backend seems to be a durable place to store your data. So by default, sorry, not by default, actually Barrier doesn't trust backends at all and only store their information in an encrypted form. So basically it means that even if someone will steal your backend or somehow copy it, he or she will not be able to use it in terms of read your data from it. So here you may see a small example of the storage console. So yeah, console is another great tool from HashiCorp. Here I also would like to pay attention on in-memory backend. So please never use this backend in your production environment. Use it only during the development. For instance, you can run a Vault on your laptop and you can use in-memory storage backend just to practice a little bit with Vault, because as soon as you restart your Vault, you're going to lose your data because they're in memory. Okay, so another thing regarding Vault is that it has a few core components: policies, authentication methods, and secret engines. How does it work all together? For example, there is a client. So first of all, the client should authenticate in Vault. As soon as you authenticate there, Vault should return you a token, and inside the Vault, this token is going to be associated with the policy. Those policies, they define if you may have access to the particular part of the system, like to secrets or to, let's say, authentication methods, or maybe to some system settings. Then, as soon as you have this token from Vault, you have to use this token for each and every communication with the Vault. So basically, authentication is just a way to go there and take your token, and then you must use this token. So this is an example of a policy. So basically, it's just a text file written in HTML format. If you guys have ever worked with any HashiCorp products, you most probably know this format. I think it's a really great way to store your policy. For example, your security team can maintain it, can store it in, let's say, GitHub or Bitbucket, for example. And it also should be super easy to audit those policies because they're all written as a very clear and simple text file. There are really a lot of authentication methods. You may see them all on this screen right now. Some of them, they are just generic. For example, it's username and password. You also may integrate your Vault with the cloud providers like AWS, Azure, and Google Clouds. You also may integrate it with some of your infrastructure tools like LDAP or Radius. Yeah, I believe that anyway, you already have one of those authentication backends, so it shouldn't be a problem for you to integrate it. But in case you do not see a method which you would like to use, so please feel free to write one because it's an open source, and yeah, you can be a maintainer of this authentication method as well. Okay, so one more thing. Today for our demo, we are going to use username and password and April authentication methods. Another thing, it's a secret engines. So basically, again, there is some generic secret engines like SSH, PKI certificates, and key volume. There are also some cloud secret engines and some infrastructure secret engines. The great thing about them that they really don't depend on each other. For instance, if you decide to move with the SSH secret engine, so there are two options: one-time passwords, and you can ask Vault to sign your SSH keys. If you would like to move with this solution, you would like Vault to sign your SSH keys. So basically there inside the Vault, you will store your public key and the private one. So the public key you can distribute across your servers, and the private one, just keep it inside the Vault. And as soon as you would like to sign your key, just send this request to Vault. Vault will sign it with the private key and send it back to you. Then you can easily log into your servers. Of course, if they trust the certificate from Vault. And that one is also going to be a part of our presentation today. No, sorry, part of our demo today. Alex, please.
All right. Oh, sorry. Now can you see my screen? All right, let's talk about our use cases and integration. Previously, I mentioned that Jenkins plays a pivotal role in our project. So we use it for running Terraform and Ansible as a jobs, as a pipelines. But it also cares about authentication. That means we don't care about any tokens, any logins inside our code, inside our playbooks or Terraform code, because Jenkins cares about it. The most suitable authentication plugin from Vault perspective is April. The flow is quite simple. First of all, you should just specify the policy and get necessary permissions to some part of secrets. After that, you should enable it on the Vault side. Get role ID, secret ID. You may consider it just like user and password. And set up the Vault plugin on the Jenkins side and specify role ID and secret ID. That's it. Moving on to Terraform. Terraform is another one famous HashiCorp product. You don't need to reinvent the wheel because everything is done before you. You just specify the provider vault, specify endpoint, and use the end secrets like data sources in your code. In that particular case, as you can see, we don't specify any tokens. Oh, sorry. Let's talk about Ansible. Just to know, Ansible is written in Python, and you should only install one dependency. It's a Python client for HashiCorp Vault. You'll install it using pip, and after that, it's simply you just should use HashiVault lookup plugin and store your secret as a variable. Finally, we came up with the idea to involve Vault in our Bastion flow. Basically, when we bootstrap, first of all, we generate the certificate authority public keys on the Vault side. And when we bootstrap our Bastion host, we share it and specify on the SSH daemon configuration to trust. After that, if I'd like to SSH to my Bastion host, first of all, I make authentication using LDAP. After that, send my public SSH key and get already signed by Vault. And finally, I use the new one signed keys to log in to my Bastion host in AWS. And let us wrap up today's presentation with a demo. Alex?
Okay, guys, so I believe you should be able to see my screen now. So the only thing that we had to record our demo just in case to avoid any kind of issues with the internet connection or maybe some other things. So it's just a video, but I'm going to comment each and every step there. Okay, so let's start. So first thing that we have to have this environment variable Vault ADDR. So there it's just an address of our Vault server. And since it's just a brand new setup of the Vault, you may see that it's not initialized yet. So what we are going to do first, we are going to initialize the Vault server, and then we will see what will happen. Yeah, so basically there are a few things. When you initialize your Vault server, you have to specify a number of keys. For instance, in this case, the key shares 5. And it means that the Vault is going to generate 5 keys for you. And the key threshold equal 3 means that from those 5 keys, 3 should be enough in order to unseal your Vault server. So as you may see now, the output consists of 5 unsealed keys and 1 initial root token. So basically, since we do not have any users there, Vault already has a user root, and we are going to use this token in order to log into Vault. So the first and very important thing, just save your unsealed keys and initial root token somewhere. And then the next step, you have to unseal your Vault. So basically, you just have to provide 3 out of 5 passwords in order to unseal it. Yeah. There's the second one. and not third one. Okay, let me stop it here. So here you may see that the sealed status here is false, and basically it means that we already unsealed our Vault server. So, and we can move on with it. So now we have to log into our Vault server in order to do anything. Yeah. Now it's initialized. So in order to log into our Vault server, we are going to use method token, and we are going to use the root token, the one which was generated at the very beginning, because that's the only user we have at the moment. Yeah, here we are. Okay, so the next step, we have to enable one of the secret engines. In our case, it's going to be SSH secret engine. Okay, so one more thing here. As you may see, there is an option path. So basically, it's a mount point. You don't have to use SSH all the time when you, for instance, enable SSH secret engine. Here it may be, I don't know, something like my prod Linux servers or my lab Linux servers or just prod or lab. So it's totally up to you. But in this case, we are just using this the mount point SSH. If you do not specify the mount point, it's going to be exactly the same as the name of the secret engine. So actually SSH. So now secret engine is enabled. What we need to do, we need to either upload our private key to a Vault or ask Vault to generate this private key and a public one for us. So in this case, we are just asking it to generate this for us. Okay, I will pause the video here. So a few things here. As you may see, there is a field, public key. It means that from the output, we just would like to see only a public key part. And as you may see, yeah, we actually can see the public key. So this public key, I would say you should save it somewhere and distribute across your server. So it's just a public key. It's not a big deal if someone will just have access to it. It's not a problem. So then you may see this SSH/config/ca. The SSH here, it's a mount point, the one you mentioned there when you enable SSH secret engine. The config and ca, it's a keyword, so you cannot change them. It's just there. It's a part of the secret engine, as I think you still remember that each and every secret engine is just independent item. So yeah, if it works for SSH, it doesn't mean that that one is going to work for key value, for example. And the next option, generate signing key equal true, means that you would like Vault to generate a public key and a private one. So it means that you're not going to upload your one. Okay. So now just let's save this key to a file. The file is going to be vault srvpub.key, and we will use it later on in order to configure our Bastion server. Now there is a really important part of the concept of the secret engines. Here you may see that there is a role. It calls role ssh.json. So basically it's just a JSON file. And within this role, we can see a lot of options. So for example, one of them is a default extensions, which is permit PTI. It also has TTL, which is 15 minutes. So later on, you will see that I will ask Vault to sign my key. And I tell him like, okay, please use the following role in order to sign my key. And you will see after that that all of those options, they are going to attach to this, to my signed key. You will see it later on. Okay. So now what we need to do, we actually have to write this role to our Vault server, just in order to use it after that. So that's again a good thing for your security team. So they can do this by themselves, and they also can grant access to only to the security team to maintain those roles. So one more thing here, as you may see, that it also looks very familiar to the previous command. So here we have SSH/roles and then role demo. So basically SSH again is just a mount point, the one we mentioned at the very beginning. Then roles, it's a keyword, so you cannot change it. But then role demo, it's just a name of your role. So basically it can be everything, right? It's up to you again. Now, another important thing, I also mentioned it already, it's a policy. So basically, as you may see from this policy, we are going to allow a user to read data from SSH/public key. So again, SSH here is just a mount point and the public key is a keyword. So if you read this data, Vault will return you the public key attached to this mount point. And another thing here is a path SSH/sign/**. Again, SSH is just a mount point, sign is a keyword, and asterisk behind it, we just hide all our roles. For example, we have enabled role demo, but with asterisk, it means that each and every role which you have attached to this mount point. And the capabilities here is update. So basically, there you might have read, update, delete, and list. Yeah, there are 4 of them. Okay, let's move on. So now we're going to write this policy to our Vault server. Then we can just refer to it by name. Again, here, policy -SSH is just a policy name, and that's it. So now what we are going to do, we are going to enable authentication method user pass. So basically, it's a username and password. Again, there is a path there, it's just a mount point. You may use any other name for this one. And now what we are going to do, we're just going to create a new user in order to use it for our demo. All right, let me pause the video here. So again, it should look very familiar to you for now. So there we again have this path auth and user pass. So basically auth, it's just a path for any kind of authentication. You may not change it. User pass, it's just a mount point. So the one we used above. So you can change it. Then users, again, it's just a keyword. And demo there, it's a username. And then you attach password to it and also policies. In our case, it's a policy SSH, the one we just created above. Okay, so we have this user. Now we need to log into Vault with as a user demo with its credentials. Yeah, method user path, username demo. Yeah, now you can see that there are 2 policies attached to this user. The one is default and another is policy SSH. So yeah, basically policy SSH, the one we just created, and default, it's a policy by default. It allows this user to have access to some system path, but it doesn't matter just for this demo. Another thing you can see here is token. It starts from S, then dot, then XY. So our user is going to use this token for all further communication with Vault. Unfortunately, we will not be able to see it, but yeah, this is how it works. Okay, so now what we need to do, we need to generate an SSH key, just a brand new. And this one we are going to use in order to log into our Bastion host. Okay, we have it generated. Yeah, so you can see that now we have a public key in a Vault user key. We have, sorry, private. The public one is in Vault user key.pub. And there is one more file, Vault srv pub.key. That's the one with the public key from the Vault. So basically we are going to use it on our server. Okay, so next step, we just need to send this SSH key, which we just generated, to our Vault server, and Vault should actually sign this and return us back the signed key. Okay, I will pause video here. Again, it should look familiar for you now. So SSH is a mount point, signed is a keyword, and role demo is just a role name. So it means that we're explicitly ask Vault to sign our public key and attach to it all options we have defined in a role demo, right? Okay, so this is our this is our signed key from Vault. So basically, we just have to save it somewhere. Yeah, let's just use this method. One thing here. So basically, as you can see, my key has name Vault user key, right? I would really advise you to save your signed certificate from Vault and just use exactly the same name and just add -cert. In this way, when you specify a key with your SSH command, you just have to specify your private key. If, for instance, you will name your file with a certificate like Vault user key, I don't know, -mycert, in this case, unfortunately, you will have to specify both your private key and your certificate when you are going to SSH to one of your servers. Yeah, it's just one way how to avoid those. Okay, so now let's try to log into our Bastion host with the key we just get from our Vault server. And before that, yeah, it's just an example how this signed key looks. So basically, here you can see that it's valid for just 15 minutes. Principal is AC2 user and extensions are just one of them is permit PTI. So the one we saw above in the role file. Okay, so now we're trying to connect our Bastion host with the signed key from the Vault, and it doesn't work, which is expected at the moment. So first of all, what we need to do with our Bastion host, basically we have to upload the public key we get from Vault to this Bastion host and then change a little bit the SSH configuration there. So for now, I'm going to use just key AWS Bastion, the one AWS generated for us when we spin up this server. Okay, the key is there. Now we have to log into this server again with this initial key. Okay. No typo. Okay, now we're here on our Bastion host. The key is here. So this is the output from the SSHD config file. Yeah, let me pause video here. So basically the whole configuration, it doesn't matter how does it look. The really important part here is just this string, trusted user CA key. And here you have to point to the public key from Vault. So the one we just uploaded. Okay, so it's there. We are going to move this key to this ATC SSH PKI. Okay, it's there. And now what we are going to do, we are going to remove this .ssh folder from our home directory. Yeah, sorry. Also have to restart the SSH in order to apply those changes. Okay. So SSH folder is not there. It means that the file with authorized keys are not there as well. And now, as you can see, we cannot log into our Bastion host with the key, with the AWS key, the one that we generated during the deployment of this Bastion host. But just a second ago, it worked. Okay, so now let's try to log into this Bastion host with the key signed by Vault, and you will see that it works. All right, it works. And yeah, as you can see, we do not have this folder .ssh, means that we do not have this file authorized keys. So it means that SSH just trusts the key signed by Vault because we have this configuration there. Okay, so I'm done with my presentation. Now we will switch to another part of our demo. Alex?
Yeah. Okay, can you see my screen again? I'm going to show you how to integrate Jenkins, Vault, and Terraform. So first of all, as I mentioned before, we should specify the policy file. As you can see, we're going to allow read operations to secrets. Now it's time to list all available policies. As you can see, we now have only two, default and root. And using command line interface, we're gonna create another one, special for a particular case for Jenkins. Okay. Let's move on to authentication app role. Let's enable it first.
Alex, we don't see your screen now.
We don't see your screen right now. Maybe you need to share again. Okay.
Yeah.
Okay.
Now it works.
Now it works?
No, it disappeared.
Oh my gosh. How about now?
Yeah, it works.
Yes, it works.
Okay. Let's continue. Okay, as you can see, I'm already enabled app role. It's already mounted to that path. It's time to create particular role for Jenkins. So I'm going to create a Jenkins role and assign a policy that I initially specified. Looks good. And it's time to generate and fetch secret ID and role ID. That the two critical parts of the authentication process. So first of all, let's get role ID. Okay, let's memorize it, that value. And now let's generate secret ID based only for particular role, Jenkins. So in other words, you'll be able to create different roles for different applications, not only for only one, under the mount point of app role. All right, let's switch to Jenkins window. We have to install Vault plugin. Let's click on Manage Jenkins and look up HashiCorp Vault plugin from available list. Yeah, it looks familiar. Okay, great. Now it's time to specify credentials. We're going to create new Vault credentials based on app role, and we'd like to specify the secret ID and role ID that actually were generated on previous step. The path is the same, app role, because the mount point is app role as well. And ID description, it's actually optional fields, but it only be used by Jenkins. So we specify role ID, copy paste secret ID. Yeah, and description, app role. Cool. Now it's time to show you our secret. We're gonna play around with key value secret. Let's get it. It comprises with key is called name, and value is going to be guacamole. So I like to integrate the secret with simply Terraform code to create new EC2 instance with a special tag name. Here are my super silly, super simple Terraform code. As I mentioned before, we just should specify provider vault, provider AWS, region profile, etc. And we're gonna save our particular secret /EC2 in data source, which called vault generic secret type and EC2. After that, we'd like to look up AWS image based on few filters and spin up EC2 instance with tag. Yeah, with tag, and it's gonna be guacamole, as we see. Right, let's jump into job. Hold on. It's time to show you AWS console. As you can see, we don't have any instances running. And let's make some configuration in our job. First of all, we should call Jenkins plugin and specify the endpoint. It's going to be Vault Skynet. And we'd like to use credentials app role from previous step. And at the end of job configuration, we're going to run two simple commands, Terraform init and Terraform apply, just to get all dependencies, get all maybe modules if you use it, and run and create infrastructure immediately. So let's click on build now and see the progress. Okay. So the main focus in my demo is to show integration between Vault, between Jenkins and Terraform. Now it's still in progress, we have to wait a little bit. And unbelievable success. Okay, it's time to refresh my page with instances. Let me check out the current region. Yeah, it should be right, should be correct. And let me refresh again. As you can see, we already have new EC2 instance with tag with key name and value guacamole. It's exactly our secret. So that's it.
Okay, guys, so if you do have any questions, now I think it's time to ask them.
So, anyone? Any questions? Well, I do have a few.
Okay.
Sure.
So, one of the questions on my side, at the beginning of the presentation, you are specifying that there are a few backends that you can use for Vault. Is there an option to have an in-memory buffer on top of the slower backend storage? Or something like a memcache setup in front of an application?
To cache it somehow, right? So as far as I know, at the moment, they don't have one. Yeah, but it might be a good feature request. Yeah, but for now they don't have one. Yeah, that's for sure.
To be fair, you'll be able to set up Vault agent, but it's not behind the Vault and secret backend. It's like front end before Vault itself. In case you have really performance overhead, we have lots of different applications that run in requests for secrets every time, every second. So it's possible solutions, but as far as I know, they don't have any, some layout between secret backend and Vault itself.
The reason I was asking is actually because my next question is a follow-up. How many requests per second do you guys manage? And this is the concern. If you end up having like 200,000 a second or something more than that on a multi-cloud or hybrid cloud deployment, then this might be a solution or something that I was thinking.
Yeah, so for now, we didn't run any performance test, but you may scale this horizontally. So basically, if you need more servers, you just can spin up them in order to, handle your number of your requests. In front of the vault, you can set up a load balancer. That one works for sure. At least in our case, we do have this. So we have a couple of vault servers and we have a load balancer in front of them. Yeah, so I would say in our case, don't remember exact number, but yeah, in our case, we don't have this problem. But I really believe that, yeah, you may scale it either horizontally or you may spin up like a more powerful instance. But it shouldn't be a problem because usually you don't let's say query a lot of information from the vault. So basically, if you need a secret, you will just go there, fetch it, and there you have a TTL. For instance, if your TTL is like 15 minutes, means that next time you will go there in 15 minutes. That's another way, I would say, a little bit play with your TTL, but it have to be some kind of balance between security and load on your vault servers.
Does
But
vault...
yeah,
Go ahead.
yeah, but I don't think it should be a problem. Yeah, anyway, you will just can scale them horizontally. That's the solution in their case.
Does Vault have the concept of federation, considering multi-cloud deployments?
Alex?
Actually, it depends on the vault type. Well, there are two main concepts. If you use open source, you'll not be able to make federation, but for enterprise subscription, you actually can to use, it's called disaster recovery.
Yeah,
If you
but
care about...
there is...
Yeah, go ahead. Sorry.
Yeah, there is another solution. For instance, as I mentioned before, for example, in our case, we have a few vault servers and we have a load balancer in front of them, right? So basically, it doesn't matter if you have your vault servers in GCP or in AWS. It's more about your backend server. So basically, if you store all of your data somewhere in backend, I don't know, it might be S3 buckets or not sure about big data. Need to check my presentation, but if you're, let me check actually.
How about DynamoDB? It's a good option.
Yeah. For instance, you may use DynamoDB, and then you can, for instance, deploy the Vault server in Azure and in GCP, and then use DynamoDB as a backend for this one, and it's going to work exactly the same way in all of those three providers, public cloud providers. Yeah, that's the way.
Cool.
I have a question. Okay.
Sure.
I have a question with regards to Vault. What is the encryption? On the security side, is there any cryptography involved? And is this, if it is this open source as well?
Yes. So basically, well, it is open source, but I also not sure if they open sourced all of their algorithms, because in some cases when it comes to cryptography, the US government they just don't allow to export those algorithms. So for this part, I'm not sure, to be honest.
Because
I never asked myself.
If it's open source, I guess anything linked to that should be also open source, right? If it's delivered as a single piece.
I think so, but it's also, it's also possible that they just use some libraries, for example. But I'm not sure. I really need to check this. I'm not sure about this. Sorry.
No worries.
Yeah, as Selot mentioned, based on his experience, there is no difference in security algorithms between open source and the premium version, which is if you pay HashiCorp for this service. I believe it shouldn't be a big difference there, but I think the question was about if you can look at their source code and find there like a specific crypto algorithms. I think it really depends on the algorithms, but I also believe that there should be a lot of open source algorithms. So yeah, in this case, they don't have to rely on the private one, like the one you cannot export due to US government or something like this.
So, any other question, guys, from the audience?
Yeah, and there is one more thing Seval mentioned there, that you can have some kind of federation with a console type of a backend and federation created by console. Yeah, it's also one of the solutions when you use console as a backend. So basically, you distribute your backend across different providers and different cloud providers. Yeah. So it's more or less the same reply. It's all up to backend where you store your data. Yeah, you can use console as well as a backend. In this case, that one will work.
Cool. So I think we don't have any more questions, at least for now. Let's have a 2 minutes break, a few minutes break, and give Seva the possibility to prepare his presentation, and then we can continue with the next.
Okay, thank you.
Thank you, guys.
Thank you.
That's the moment to open up a beer and follow the next one.
Is everything works? Can you see my screen now?
Yeah,
Yes, we
mountain.
can. A mountain. Actually, we
right.
see the background.
Yeah, give me a sec. I will share.
I think you need to drop it, yeah, from one screen to another.
Yeah, it's probably works. Should work right now.
Yeah.
Yes, it does.
Nice.
Perfect. Great. So we are set for the next one. Let's wait for another two minutes, and then we can just start.
Yeah. Okay, I'll be back in a few minutes.
Perfect. So everyone is so quiet. Why is that?
Because we are muted.
Everyone is muted. Yeah, good point. Well, in normal circumstances, this was supposed to be a fun event where people joke and have some beer. So
We can turn on all our microphones and start talking.
yeah, well, not during the break is allowed, right? Not during the sessions. So yeah, I just took my beer. It's a shame that we can't have one together, but next time we'll make it happen, hopefully.
Yeah.
Hopefully it's gonna be not Heineken or Amstel.
No, actually, I discovered a new one, which is a Grolsch IPA, which is quite good.
Gosh, yeah, nice one. How about Jochen
Yeah.
from Haarlem?
Oh yeah,
Have you tried it?
really good one. That's probably better.
You're a sinner because
Really
it's in
good
fact
beer.
it's church with brewery inside.
Yeah, I've been there once, and I was pretty impressed, I would say. And the quality of the beer, the craft beer here, amazing.
Yeah.
Okay, okay. Is everyone ready? Seva,
Yep,
can we
I'm ready.
start? Okay, let's.
Is chat ready?
I think it is.
Yeah. Okay, so my name is Seva. I am a software engineer at VictoriaMetrics. You can find logo of VictoriaMetrics in the right corner, right upper corner. So when I was a child, when I was a kid, my mother used to tell me a lot of stories, a lot of fairy tales about knights, about elves and other fantasy crap. So, and I want to tell you the story, one of the story today. This story about Sir Alex and the Pigeon Post. Actually, it was one of my favorite bedtime story. So I hope you find it interesting as well. At first, I mean, I know a lot of stories about Sir Alex. It was like maybe a full cycle of stories. It was big, like a lot of Lord of the Rings stories. It was a really big cycle of the stories. So, how Squire Alex, become a knight and become a seer? At first, he found a holy grail of regular expressions. It was a really nice story, but it was really hard to read. Then he won a combat with a log-tiling hydra. So it was actually one of my favorite stories about how Sir Alex found a sense in tailing dev random. Then was a story about Sir Alex, how he saddled a blue whale at the docks. Actually, it was includes a lot of containers and ancient Kubernetes cores. And he became a knight of land of Go because he lives in Go Kingdom, and only that one who lives in Kingdom of Go can be a knight of Go. Actually, there is an other part how Squire Alex become a knight. It was because he built a VictoriaMetrics monitoring solution. He built it protocol agnostics, and he allowed this monitoring solution speaks Graphite, Influx, OpenTSDB, and Prometheus protocols. He built it really efficient, like 3-time or 100-time efficient usage of disk space, like 100 times better than Graphite. I mean, comparing sample size, it's Graphite have sample size of 40 bytes, and his monitoring solution has only 0.4 bytes of sample size, and it's 4 or 5 times better ingestion performance comparing to the leader like Influx or other monitoring solutions. He created this monitoring with really user-friendly query language, and I cover it later. Because Sir Alex was a really kind knight, he allowed this monitoring solution to support push and pull model to get metrics, and he built it completely open source and free for everyone. So, I mean, Squire Alex was a pretty nice guy, and there is time to start our story. I mean, right now you know almost everything about Squire Alex as me. So, once upon a time, the king come to the knight Alex and ask for help. "The mighty knight Alex," king said, "kingdom need your help right now. As you know, all kingdoms is under a quarantine, and the only way we can communicate with each other is a pigeon mail." Yeah, I know, Sir Alex said. "But what the problem?" "Oh, we're not happy, and we don't know why we're not happy, and people not happy, and we don't know why people unhappy. Those people said that our pigeon mail system is bad, and they didn't receive a mail, but we didn't understand why. So you need to build the best pigeon mail system in the world." Yeah, but what you already tried?" "Oh, we tried a lot," King said. "We tried to make pigeon faster, even used a small rockets, but we didn't understand actually it helps or not." "Okay," said Knight Alex, and start to think how he can measure observability of the pigeon post. He started to think, and he found a pretty simple solution. Knight Alex give an order to count how many pigeons go out, how many of these pigeons get back, and total time spent by all pigeons to the message delivery. After that, he just take the all time spent by all pigeons and divide this number of the count of the pigeons. With this number, he can build a pretty nice graph. It's called average, because he starts to understand that average time every bird spent to deliver a message, it was pretty okay. And it looks like valid data, but when Knight Alex starts to do some experiment, he found that data looks like valid, but actually no, because he add small rockets to the birds and it didn't correlate to the graph. And also his friend Sir Lancelot starts complaining about speed sometimes, and this complaining doesn't correlate with average bird time spent to message deliver. So Sir Alex take his favorite pink pencil and draw a line of the time spent by birds to deliver message to Sir Lancelot. And he found that actually time spent by birds to deliver message to Sir Lancelot doesn't correlate with an average time spent by birds at all. Why it can happen, thinks Sir Alex. He take another day or two for thinking and draw a really bad graph with all time spent by all birds. So each dot represent the time spent by bird to deliver a message. In this graph, Sir Alex found that some birds, most of the birds spent from 1 day to 2 days to deliver messages, but there was messages which was delivered for 10 days or for 5 days and for more days. And because these values was so big, they really affect the average graph. So Sir Alex starts to think how he can make the data more useful. He thinks day or two, and then he go to the secret forest and found a secret mountain, and in this secret mountain was a secret cave, and the old warlock lives in this cave. Sir Alex come to this warlock and ask, "Hey warlock, how I can make data more useful?" "Oh, I don't know how you can make data more useful," warlock said, "but probably we can ask a demon of statistics to help you." Yeah, why not? We can ask a demon of statistics, said Sir Alex. And warlock starts to pronounce an ancient spell on the language of JavaScript, and he recall a demon of statistics called StatsD. I mean, because it's statistics demon, it was his name. And that demon of statistics said, "You need to sort all response by time. You need to remove n%. You need to remove all values above n% and remove all values below n%. Sir Alex understand nothing, but demon already disappeared. So Sir Alex asked Warlock again to recall the demon. Warlock said that I can show you what demon means, and draw a small table. In this table, he said, "Okay, let's assume we have 10 birds returns this week. That means you have 3 birds which deliver letter in 1 day, 1 bird which deliver letter in 2 days, 4 birds which deliver letter in 3 days, and 2 birds which deliver letter in 10 days and in 17 days. Total you have 10 birds. If you take the sort value in our sorted list, that will mean that at least 3 users received letter in 1 day. And that means that at least 30% of your users receive letter in 1 day. If you take 8 value in this sorted list, that means that at least 8 users received mail at least in 3 days. And if you take 9 numbers, that means that at least 9 users receive letter in 10 days or faster. It was pretty simple explanation, and Sir Alex understands that percentiles means the worst case scenario for n% of users. He starts to build the nice percentile machine for understanding how the things works. For having percentile, you need to store all events, then sort these events, because you need to take some specific value, and then you need to pick the single message to understand which value percentile has. But after some time, he found some disadvantages of percentiles. That was pretty major problems, because you need to store all messages. You can't really do any aggregation with percentiles. And the second problem was that percentiles can be processed only from a single tower. And actually, you need to spend a really lot of time if you want to have percentiles for day or for week or for 1 month, because you need to collect all information, then sort this information and then do some aggregation. It was okay, but actually didn't help a lot. After some time spent, Sir Alex come to another magic forest. I mean, there was a lot of magic forest in those kingdoms in those days, and he meet the great wizard whose name was Rincewind from the Great Unseen University. How to trick the law of nature called math? Asked Sir Alex. Wizard start to think, and he come with answer. You can use histograms. You need to split your data to buckets and increment the buckets instead of sorting all information. And you, with this type of storing data, you can aggregate data over a time. Let's imagine you have the same birds you already have, which deliver letters. Instead of sorting the whole information, you can just count how many birds have some specific value. I mean, in this data, that means you have 3 letters delivered in one day, 1 letter delivered in single day or in 2 days, 4 letters delivered in 3 days, and 2 letters delivered in more than 5 days. So if you can find a nice bucket size, you can aggregate data over a time because it's a really simple operation. And you can build a nice heat map graphs with all this data, which on these heat maps graphs, the color represent actually how many birds, how many letters was delivered in some specific range of time. Sir Alex built these heat map graphs, and he found that usually 99% of users was received mail in 3 days. Actually, it was okay. It works for the total mail, but after he have this type of observability, Sir Alex starts to thinking to split this data to internal city mail or intercity mail and for international mail. And he found that all the nights have different ideas. I mean, like the city posts and inner city mail system want to use really small buckets, but international mail want to use a really big buckets because he works with international mail, and he didn't need this detailed information as can be needed for city mail. So after some big fights between postmen, Sir Alex wrote those disadvantages of histogram. First of them was you need to know bucket size before data collection. Some of users want to have a really big buckets, other users want to have a really small buckets, and you need to know the bucket size just before you have any actual data. The second problem was low resolution. You always need to check, you always need to compare. What do you want? You want a low resolution or you want a high number of buckets? I mean, if you want to build the whole universal system for histograms, you really need to see what it's worth. And if you want to use a different bucket size for different systems, it's really hard to compare and really hard to aggregate those buckets because of law of math. So Sir Alex was really disappointed, and he starts to think who can help him with building a better system than usual histograms. Actually, histograms works pretty fine, and a lot of other kingdoms used histograms, but probably there is a better solution. After some thinking, he met the beautiful and nice princess, and this princess said, "Oh, Knight Alex, you can use HDR histograms." "What that mean?" asked Sir Alex. HDR means you need to split all data to some big buckets, and those buckets you need to split to some smaller buckets, and smaller buckets you need to split to other smaller buckets. So Sir Alex did this splitting, and he starts from 10 in degree 18 and do splitting till 10 in degree minus 9. And he split each time he do splitting for 18 buckets. It was pretty well-designed system. That means at the beginning of the graphs, it was really high resolution, because each time he can bucket split it for 18 more buckets. And it was a really low resolution at the end, because each time it was split more on more to 18 buckets. Actually, Sir Alex was so happy, so he built additional histogram and Prometheus buckets functions for VictoriaMetrics for converting VictoriaMetrics histogram buckets to Prometheus compatible buckets. And also he created some other functions just for working with these histograms, like histogram over time for calculating histogram for gauge values M over the given time window D, histogram share for calculating service level indicator like SLI or SLO, and share LE over time for calculating SLI, SLO for gauge values. After some thinking, the Knight Alex will open source the HDR libraries for Go language. It's called VictoriaMetrics/Metrics. And he found that in the other countries already used HDR histograms. He passed some links to the library used to the libraries on these languages. Right now, everything works fine and people are happy. They're happy because you can do some comparison of histograms, you can do some comparison of values, you can use HDR histograms without thinking which data you have. You don't need to think about the bucket size, you don't need to think about any other ideas. But he has some plans, because that's Sir Alex. He's always have some plans and he always thinks about improvements. First idea to improvement, it was offset support, because right now HDR histogram starts from 0. But what if you want to have a lot of details and your default values is more than 0? And the second idea is having automatic offsets for HDR histograms, because that can be calculated if you can just store some values inside the memory, like first 100 or 1000 values, you can store it to memory, and because of this you can calculate offset. Third idea, it was support other protocols, because right now Go implementation supports only Prometheus protocol, but there is also language in other countries, and because VictoriaMetrics supports all protocols, there is the idea to support other protocols to this library as well. Yeah. So that's probably all. This is the whole story. You can find a link to VictoriaMetrics database here. You can find the link about the GitHub of VictoriaMetrics because it's totally open source. There is a link to our Slack community. Please join us. We will be happy to answer to any your questions. And there is my email. You can drop me a letter, and I will be happy to answer. The main idea, the kingdom was happy and saved by HDR histograms. Thank you.
Thank you, Seva. That was an amazing and unexpected presentation. I'm so happy you did it this way. It was out of the ordinary.
Thank you.
Yeah, the first question I have is like, can we drop you pigeons?
Drop pigeon? I'm sorry.
Yeah, instead of letters, or letters with pigeons.
Yeah.
Amazing way.
Oh, yeah. I'm sorry. Yeah. You can drop me a letter or pigeon. I mean, you can drop me anything you want.
Cool. That's cool. So, guys, do we have questions in the audience? There is nothing on the chat, but maybe you can just go live and ask questions.
Yes, I have. Thanks a lot, Seva, for this amazing session. One more question. Who had drawn your slides?
Actually, it's. I draw it myself. If I have a kid, I will say that I have a kid and kid do the images, but actually it was myself. I have really mad skills in drawing.
Awesome, thank you.
Any other question for Seva and the VictoriaMetrics team?
I have a question with regards to your portfolio. I mean, what would be, how would you advertise it? And, maybe you can give us an idea about some of your customers and.
Oh, yeah.
And scale, basically, and some of their scale,
Yeah, so in VictoriaMetrics we have a lot of users. I mean, we go open source the last summer, and right now we just starting to grow. But we already used by companies such Adidas. We already used by company Wix. It's only public cases. Give me a second. I will open the. We have a really lot of customers right now, and usual scale. It's like more than 5 million metrics per second we can work. It's we can work with pretty high load setups. Probably Artyom can add more information in chat, or Sasha. Yes, Alex already posted a link to our case studies. It's only public case studies, but we start to collect public case studies, and in last months we add 5 more. So probably there is more case studies in next months as well.
Well, we hope so.
Yeah.
I have a question, a functional related question for you, because also on my previous job I was following you closely. As far as I remember, the cluster version setup, in the cluster version setup there was no replication supported. I'm not sure if this is the case today, but it used to be like 6 months ago or 7 months ago.
So in VictoriaMetrics we have like 2 different models of cluster. You can think about this like RAID 0 and RAID 1. With RAID 0, it's usual cluster version. You can write a data to like RAID 0 to every, not to every copy, but some metrics go to the server 1, some metrics on the server 2. if you want to have a replication like RAID 1, you can just up two separate clusters to separate storage and use VM agent. Its tools we released maybe months or 2 months ago to write the messages to the both clusters. So actually we're thinking about adding some kind of replication which already works for Graphite. Probably we will do this in the next few months. But right now we don't have any customer, any user who really wants this kind of replication, because I mean RAID 1 and RAID 0 is okay for everyone. So
Yeah, the reason I was asking is mostly because if you have a huge amount of data, which some companies have, you want to have the fastest cluster in front and then replicate this as in the back end to another slower cluster, but just to have data consistency and resiliency there. So maybe you can query the back end and only actively write to the one in front, which is the fastest one. Okay, I get it.
Actually, you can just probably you can do this with some kind of snapshots and backups. Actually, it's a really interesting question because it can be really difficult system, but we works on some like tools for backupping to S3 and not backupping but syncing data. I mean, we have really great plans in the future how we can improve everything, and everyone, if they have any ideas about how VictoriaMetrics can be improved, we're really open to some issues. I mean, you can create issue on GitHub, and we're really open to any possibilities.
So yeah, to continue this trend of the discussion, I was actually willing to know what are your plans in regards to Graphite, and is this are there further plans to be supported and adding more features Graphite related, or not specifically?
Yeah, we already support the Graphite protocol. I mean, like we support a lot of different protocols in Flux, Graphite, OpenTSDB, Prometheus. I mean, we just support all these protocols, and all protocols is first-class citizen, so there is no difference which protocol to use, and it didn't affect it didn't affect ingestion and performance. About the supporting of Graphite functions, we have some ideas to. I mean, VictoriaMetrics already supported by Carbon API. It's like a Golang API for Graphite, for GoCarbon, and as I know, VictoriaMetrics already supported, but I didn't do any tests. So, but we open to other ideas, like to support the whole language. I mean, the whole Graphite language as well.
Thank you. I mean, how is the easiest way to contribute to the project, or maybe ask or initiate a feature request? Because us, at least in Booking, we have a huge Graphite infrastructure, like really big one, and it would be interesting to know how we can easily get in touch with you guys and propose some features.
Actually, there is a lot of way how to communicate with us. We have a Slack chat, and if you want to use the VictoriaMetrics in your company, we can schedule a call and create some special private channel in Slack and do some communication in this private channel. Also, we really open to the issues. You can create issue on GitHub. You can create a pull request. We really open to the community right now. But probably the best way is to schedule a call. I can write a letter to you after this meeting, and we can schedule a call.
Sure, sure. That would be amazing. That would be awesome. I think yes, I have a few of my colleagues directly involved with observability and graphite. Arna already asked the question, so yes, that would be quite an outcome of this meeting. It would be interesting.
Nice.
Good. Any other questions in the audience, guys?
I have
Now's the
one
moment.
question.
Go.
I was reading about this HDR histogram because it seems very interesting, and it's the first time I actually hear about that. But I also read that there's a lot of memory footprint for using it compared to normal DK histograms. Do you have some input on that?
Yeah, actually, usually, I mean, if I understand the question correctly, usually in basic HDR histograms, you split data to a lot of buckets. But in our client, we split the data only to 18 buckets per each period. I mean, like we split to 18 buckets, 10 minus 9, 10 minus 8. Then we from 10 minus 8 till 10 in the power of minus 7, we split to another 18 buckets. So we take a real world data and we do our optimization, and actually it works really well right now.
May I?
It's just, sorry.
Yeah. Actually, Alex can help.
There are HDR histograms, as Teva already said, from Java world, which split the full range into 30,000 buckets probably. This is an enormous number, and it doesn't work in practice when you want to store a big number of histograms in time series database, because each histogram which will require storing 30k different time series. So we decided to reduce the number of such buckets in VictoriaMetrics, but leave the same scheme of splitting these buckets as in HDR histograms. And our scheme, as I already said, just works for major practical use cases quite well. Of course, it cannot cover some edge cases when you need higher resolution, higher definition for your samples on particular range, but such cases are rare, and in most cases when the value is time or for instance response time or response size, for such values histograms from VictoriaMetrics work quite well. And additionally, VictoriaMetrics doesn't store all these buckets for each histogram on full range. Stores only buckets, non-zero buckets. It means that the buckets which have at least one value, and usually in practical cases values are spread on quite small range, which is covered by small number of buckets in VictoriaMetrics histograms. For instance, up to 20, up to 30 maximum. For instance, 30 buckets cover range from 1 to 1000, or any other range which can be multiplied by any power of 10. So it works quite well in practice, and doesn't require much resources on VictoriaMetrics, on time series database and storage side.
Okay, thanks.
Quick quick question, at least probably the last one on my side. What is more expensive in terms of resources, the writes or the reads? Because from experience using a lot of OpenTSDB in the past, the reads were a lot more expensive than the writes.
Actually, yeah. Alex?
Okay, I will try to answer this question. It depends, because VictoriaMetrics is optimized both for data ingestion and for data reading, so it works quite fast. For instance, it scales to 500,000 series per second per CPU core for ingestion rate, and it scales to up to 50 million samples per second scan speed for querying this per core numbers, and it scales to all available CPU cores on machine which it runs on. So it works faster on both ends. And
yeah, actually it works pretty fast, mostly because Sir Alex did a lot of tasks to make the sample size really small. I mean, if you need to read not a lot of data, and if you need to write not a lot of data, it's actually faster than everything. And we have some comparison. We have like crazy numbers of ingest comparing to Influx or Timescale DB, and actually crazy fast reads. It's really hard to say which bigger problem right now. I mean, it's like mostly reads are better right now because it's usually it depends on how much input output how much IO you have. If you use some kind of AWS, it's probably the same, because in AWS you have the same amount of IO to read and to write. If you have some bare metal, probably it will be much easier to read, mostly because you read faster in bare metal than writing. But I mean, it depends on disk system you used.
Yeah, I was about to ask you about the IOPS needed for both read and write.
Okay, about IOPS, VictoriaMetrics tries to store all samples for each time series in contiguous areas on disk. So when it reads a single time series data, it usually needs only one read operation for reading any number of time series up to one block size, and one block size is 8,000 samples. So for each 8,000 samples which belong to a single time series, it needs only one read operation. And this quite contrasts to comparing to storage schemes which use it in Whisper and Graphite, which usually store each sample in distinct parts of distinct parts of disk, and this because it stores each sample for each time series at different times. So these samples go to different parts of disk, and so if you need to read many samples for the same time series, you need to make many read operations. And VictoriaMetrics only needs to make one read operation for reading all this data.
Yeah, that explains it. Thank you. Thank you for answering this. Is it possible to have some sort of a setup where you have a cluster for ingestion and a cluster for read? Because most of the I mean, imagine a company full of people having this monitoring system based on this backend, and all the dashboards loading every 5 minutes in the background. All the Grafana dashboards, always querying the same data, or maybe the new data.
I'm not sure that I'm totally. I mean, you definitely can write data to separate clusters. I mean, like you can write the data to different clusters and use those clusters separately. But if you want write data to some one cluster, then read data from the other cluster with other disks, it's really hard. I mean, writing data, it's the same amount of data. I mean, there's no difference between replication and writing the data from VM agent as example. So I mean, yeah, it's really possible, and you can have like a separate cluster of select nodes which do all the math and have some caches and other things. You can just have them on the other machines, and it really helps to cache in some answers.
Well, thank you for answering. Thank you. That explains a lot. Any other question, guys? Well, it looks that we kind of consume all the questions. Thank you for the presentation. Amazing one. Both presentations really good. And just before we drop off this call, I will follow up with a Google form, and please give us feedback. And for the presenters, guys, if you can share the presentations with me, that would be great. I just want to share this to the community. And
sure.
we can follow up after. Thank you everyone for attending today. That was amazing.
Thank you for organizing all these things.
And as I said last time, if you have ideas, if you want to present something to the community, just contact me on the Meetup or LinkedIn or where you can find me, and we will be more than happy to support it and to help you present your ideas. This is all about this community, presenting how we do things, how we fail, and how we succeed.
Yeah, thanks. And I hope that the next meetup will be not online but offline.
Yeah, I owe you beer, as I said at the beginning. I owe you a lot of beer. So yeah, I really hope so. Until then, stay safe, take care, and I hope to see you soon, as soon as possible.
Yeah. Bye, everyone.
Thank you. Thank you.
Bye.
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 Thank you. Cheers. Bye.
Bye.